Good afternoon. I'm on site here at Embedded World 2022, and joining me today is Dzianis, Director of Platforms and Solutions for Industrial Automation at Analog Devices. So thank you very much for joining me today. Now we're going to be talking about embedded, flexible, scalable and intelligent platforms and solutions for Industry 4.0. So could you start by telling us what is actually meant by a flexible, scalable and intelligent platform or solution?
Sure. So in a factory, different pieces of equipment of different manufacturers need to work in harmony, first of all.
Yeah.
And such a platform or solution should fit as many applications as possible.
Mm-hmm.
It is what our customers want, and this is about flexibility. Those components need to be intelligent to work independently and self-sufficient and take over some tasks. And of course, those platforms can be adopted for small size, customized solutions,
Mm-hmm.
as well as to be able to leverage mass production.
Mm-hmm.
It's about scalability.
Okay, fantastic, thank you. And can you give us some examples for such an industrial platform or solution?
Yes, let us consider a sort of intelligent or smart input-output box. It can be the same input, the same pin, the same port can be used for sensing, and to any sensor can be connected to this port, and any actuator can be connected to this port. And our customers don't need to care about that, what is connected. It used to get the data in and to get the data out. This kind of platform should talk any of industrial protocols.
Mm-hmm.
It's expected by our customers to be integrated in their enterprise system. And of course, those kind of boxes should have some sort of intelligence to read this data, to analyze this data, and make a decision based on this on analysis of this data, and then send this decision over the industrial protocol to the enterprise into enterprise cloud, for example.
Mm-hmm.
And of course, only relevant or meaningful data needed to be transferred to the cloud for post-processing. Of course, if somebody wants to have all the data, raw data, and post-process them in the cloud, it can be done as well.
Okay, fantastic. And what role does Analog Devices play in all of that?
Yeah, well, Analog Devices deliver key impactful technologies for that kind of application, as just mentioned it before. For example, it's ADI software configurable IOs, input-output components, where any IO function can be accessed by any pin and changed on the fly anytime.
Yeah.
It's also ADI Chronos industrial Ethernet technologies, hardware, software, firmware we deliver to our customers. It's ADI artificial intelligence portfolio on microcontrollers with embedded hardware, convolutional neural networks accelerator, for example, and of course ADI portfolio on secure microcontrollers to fulfill industrial standards in that area as well.
Fantastic, it's a nice portfolio you've got
and
there.
Of course, we support our customers with reference design, with functional blocks, signal chains, domain knowledge, as well as with software development kits.
Yeah, of course. And Industry 4 applications generate a huge volume of complex data, which naturally increases the potential for generating added value along the entire value chain. But how exactly can this potential be extracted?
The most usual way or common way is to take the data from the sensor, stream it into the cloud system, and do the whole post-processing in the cloud. It's still the most used approach, but not really efficient, because it costs a lot of storage, a lot of power for that, and it's also extreme complexity in the cloud system. What does make sense that the most relevant, most meaningful data, we call it smart data, will be extracted close to the sensor. And in this case, you might reduce complexity for post-processing. You also need less storage and power consumption. A good example here is that if you use a wireless system, for example, sending any bit of information through wireless is much more costly compared to the local processing of the data close to the sensor, for example, right? And only in this case, the economic value can be extracted if you take all the data, condense the data, and send the only relevant data for these applications for your machine, for example, to the cloud for future post-processing.
Okay, and at what level then is it best to extract this smart data that you speak about?
Well, it also depends on the application, but it depends where do you want, what the data, where the meaningful data, or let's say the relevant data can be extracted, and which resources are needed.
Yeah.
It can start with a small sensor with restricted embedded computational resources, and end it into the cloud where you have all the computational power. A good example here is if you think about, for example, a device monitoring machine health,
Yeah.
right? So you can, this device can recognize right at the machine if the machine is working okay or not okay. And if the machine is working okay, you just need to send okay to the cloud. You don't need to send all the sensor data. And if the device recognize a fault, for example, it says it's a fault, but I don't know what the kind of fault is it. In this case, you can pass all the data from the sensor to the cloud and do advanced analysis, and then you know exactly what kind of fault is it, and you even can give an advice to a technician what needed to be done to avoid these faults in the future, and for example, what needed to maintain this machine.
Okay, excellent. And what role does artificial intelligence play in smart data extraction?
Well, AI, artificial intelligence, is playing a key role here, key supportive role. If the application, the use case is well known here, then the AI algorithm can be quite rudimentary. It can be really embedded close to the sensor, for example. If we don't know about the application too much, or the data flows are extremely huge, in this case, you can write standard AI algorithms where you don't need to take care about the power. You just, you solve your problem by computational power. But if your resources are quite limited, then you need to optimize your algorithms you want to use for AI. And finally, it's an application, or let's say it's an application which limit the hardware, or let's say define hardware requirements, as well as AI algorithm use it on each stage of information extraction, for example, or getting relevant data.
Okay, interesting. So following on from that, do you have any specific applications in mind?
Yeah, it's a good example here is ADI AutoSense smart motor sensor. For it's a condition-based monitoring box for electric motors, where the AI is actually split it into small pieces. It starts from the box. It's a box which can be screwed to a motor.
Yeah.
And this box can learn the machine behavior. You just say, okay, learn my machine, and of course you know before the machine is working right. And then this box can recognize some faults of the machine and say, okay, we have a problem with shaft, for example, with special bearings.
Yeah.
But as I said, the resources are quite limited in this box, and of course we can cover some use cases, some faults. In case there's something totally unknown happened,
Yeah.
we just take all the data and send this data on the cloud, where AtaSense will analyze this data and then help the technician to find the fault and initiate the next steps, for example, right? It's full turnkey solution from the sensor, smart box, through the edge up to the gateway.
Fantastic application. So how do you see smart embedded sensor platforms such as what we've been speaking about? You know, how are they going to be in the future?
Yeah, it's a good question. I think it's called smart sensor and actuator hubs, smart devices. Finally, those kind of let's say devices should be smart enough to understand what sensor is connected to this device, then do analysis of this data and do also qualify the data. How good are my data? Is it really the data what I really want, what really correspond to the reality? And if you talk about sensor fusion, where a couple of sensors used for monitoring, back to example with machine health, then AI is mandatory here, because you need to analyze different sensor data. You need also analyze the independence between sensors. And in this case, AI can help you to condense the right information from all the sensor fusion data. In case a sensor is not relevant to this application, you can decide not to use the sensor or switch off the sensor, for example. And of course, you can extend it from the sensor front end down to the communication standard, where the box decides what's the language I want to talk to the enterprise, right? I mean, if you take whatever 5 big industrial protocols, the device can decide which protocol the enterprise won't talk to me, and I just load this protocol and talk in this protocol, this language, to the enterprise cloud system, for example. It's becoming really self-sufficient, self-learning, taking over more and more tasks, and making our life easier, or life of people and designers, and especially in the smart factory, a life of technicians very, very, let's say, more easy, more convenient. Yeah, that's actually the AI who will drive the future of smart sensors.
Oh, fantastic, that's really interesting, thank you. Well, thank you very much for your insights today.
Thank you for inviting.
I hope you enjoy the rest of the show.
Thank you.
Thank you.